Hello. Hello. Can you hear me? Okay. Good afternoon, everyone, and welcome to our tutorial on data collection and end-to-end learning for conversational AI. So, before we start, several disclaimers. The focus of this tutorial is basically not on the entire landscape, not on the entire. Maybe can I get a mic? 'Cause Okay. Okay, this is better. So the focus is not on the entire landscape of conversational AI because it's just too broad, too many things happening at the moment. So we're gonna cover like two recent, like very popular trends in conversational AI, which is building new data sets and building end-to-end models that learn from these data sets completely in an end-to-end fashion. And so I'm Ivan, and this tutorial is done together with Paweł and Iñigo here. So we are at PolyAI and affiliated also with the University of Cambridge. So we'll start from the very basics. So maybe the first part of the tutorial, many of you will actually know these basics and how like the concepts behind modular task-based dialogue systems, but we kind of have to cover to really show what we'll focus on later on in the tutorial. So we'll start from Hollywood, basically. And so Hollywood has done maybe a lot of damage to the reputation of conversational AI and what it can or cannot do. And basically, the way it is depicted in all these movies, I hope that you recognize many of them, is basically, it's kind of like the whole AGI is solved, and these assistants like Jarvis in Iron Man can do whatever you want him to do, like hold intelligent conversations, solve tasks for you, give you information, etc., etc. So, but actually, it goes towards the right direction, towards the direction of these intelligent virtual assistants, which is what we are trying to actually build. Like many companies, like big companies as well as smaller companies, are actually investing a lot of time, effort, and money in trying to build like virtual personal assistants that can do a lot of things for you, like from task completion to decision making, etc. So in 2019, like the focus is pretty much on trying to make a lot of virtual personal assistants work and make your lives easier, from like healthcare, daily routine planning, etc. But how the whole thing started, so we can say that maybe one of the first conversational AI systems was Joseph Weizenbaum's Eliza, which was basically just like a bunch of rules, less than 200 lines of code that kind of provided support and sort of therapy to the users, and he gave it, I think, to his assistant, and they talked for hours. But it was basically just a bunch of rules, and of course it wasn't like general intelligence or anything like that. While today, in what we call the age of virtual assistants, what we are actually trying to do is really use conversational AI for particular purposes. Like basically, let's talk about two paradigms. So the first one is building assistive conversational tools that kind of help humans to accomplish certain tasks quicker. For example, if you talk about customer service or call center support, maybe these conversational AI can actually capture some of the evidence clues from the user's utterances and make the whole filling in the forms process much quicker for the actual worker on the service side, etc. And we can also talk about full automation, where you're really trying to accomplish the full task using like a system agent, which is basically, if I want to like call a restaurant to make a booking, I can talk to the system agent and it will do all the steps without even having human in the loop. Okay, that's sort of an utopia, but it might work for like simpler, smaller use cases. And yeah, so basically we kind of have these two different applications at the moment, and conversational AI is used across so many domains. So we're just listing some of them here for like call centers and customer support that I already mentioned. They could be used for like a lot of bookings and search in hospitality industry for hotels, flights, train tickets, etc. You can use it for like FAQs in many domains to support e-commerce, accounting, finance, and your daily life routines, like from like these one-liners and utterances where you set up your alarm clock or you need to be reminded about when to go for a meeting, etc., etc. And yeah, the question is, are we there yet? So all these applications are supported, but to what extent? How well does it work? And do all these different domains or tasks actually require different data sets? How do we collect data for all these applications, and how do we model? Like, is there like a difference between setting your alarm clock versus just like building a full-fledged, fully automated system that does your restaurant bookings, etc.? And so some of the tutorial goals here are basically, to get you up to speed with cutting-edge data collection paradigms in conversational AI and how people actually approach data collection, both from research and industry perspective, and also touch upon a very recent trend of using large conversational data which is not annotated, like, for example, Reddit conversations or internet forums, to do some sort of conversational pre-training prior to usage. So this is all like 2019 stuff that we're going to talk more about it. We're going to talk more about it later on, and we'll also give a brief overview of how to do end-to-end data-driven dialogue learning, mostly focusing on task-based systems. And also, it's more like a discussion point where we're going to talk about data collection versus modeling, and like what seems to be more important and what seems to actually boost your final task completion in a sense. And finally, we also give some of the industry perspective based on our recent work in the company on like what works and what doesn't work. And so this will be a slightly subjective, so you can disagree with us, but we just wanted to share some of the experiences and best practices we encountered working on those problems. So as I said, the focus will still be on task-based systems, which again might be slightly subjective, but because my personal opinion is that task-based actually means building something useful, which is not having this like long-standing goal of solving artificial general intelligence, but really trying to complete specific tasks in well-defined domains without actually spending too much time and effort trying to build bots that carry out general conversations. And so this is related, for example, to the Google Duplex initiative that you probably heard of, where the idea is really to build these task-based systems that can book you a hairdresser's appointment or book a restaurant, etc. So it's under this paradigm. So as mentioned, we kind of have two big paradigms. So the first one is really building these task-oriented systems where you really have this well-defined domain and you kind of know what your system can or cannot support, and the user should also be aware that the system is basically built to complete a particular set of tasks or just one task, like restaurant booking and searching. While the other paradigm is really trying to build these open domain chit-chat systems where you can talk about basically everything, about the meaning of life, or if you want, and at the same time they should also book restaurants for you. But yeah, the world doesn't work that way. It's kind of, if we divide it to like different sorts of problems that we are trying to solve, I think the problem of open domain chit-chat systems is really like the problem of general intelligence, which is basically the idea is to pass the Turing test, so to have a system that talks like a human. While the other three questions are much well defined and they kind of do something, I wouldn't say more useful than general intelligence, but something that the machine can do to support humans. So which could be information consumption, which would be the task where you kind of just ask questions, like more factual questions, like where was Donald Trump born, and you can get the answers from the system. So think of it as question answering applications. Or and task completion is doing something useful like booking restaurants, or decision support, where you can actually have maybe slightly a more high-level defined questions like, should I invest into this particular property? And then you might actually get some information from the system because it will understand, okay, you're asking about some like finance advice, and it will give you some information that you can process or data mine much more quickly than what you would do by just Googling it. So currently in the conversational AI landscape, only like the latter three tasks are actually supported by task-oriented dialogue systems. So that paradigm supports what we think is currently the useful part of conversational AI. And basically, all the virtual assistants are also focusing on making that happen, on solving these three different tasks in a sense. So here is the short overview of the main properties of these two paradigms. So as I said, task-oriented need like really precise understanding and at least some in-domain data. So we can't really teach our system to do anything meaningful if we don't have the data for that, of course. And so right now, so many of the work, much of the work in task-based dialogue systems was based on these like pretty intricate modular systems that contain like 6 or 7 modules. We're going to show a brief overview later on. And then there are like 2 questions here. One of the first questions is like, can we do end-to-end learning by passing the modular structure? And the second question is, can we also use unstructured out-of-domain data for some sort of pre-training? So that's what happened actually in 2019. On the other hand, open domain chit-chat systems actually do not have well-defined goals and semantics of the task, and they can be trained on large amounts of unstructured data in an end-to-end way, and they're quite interesting because they're generative, can learn unexpected creative responses, etc. But the problem is the responses they generate have a lot of problems. So they're often meaningless, inappropriate. They're unreliable as generative systems because you don't know what to expect, etc. So I think, yeah, the idea is to, as I said, to show an overview of task-oriented end-to-end learning and some recent advances which try to combine unsupervised end-to-end learning on unstructured data with some fine-tuning on in-domain data. So this is just a brief overview of some of these seminal works on open domain generative conversational models, where like now from this perspective, this is kind of like a simple approach that just tries to do some seek-to-seek learning based on like raw text that you just get from the internet. And yeah, you can train a large model on large corpora, but yeah, can you tweak it for the particular domain? And so one of the basic questions is in the actual production, can we really trust generative systems, or do we need to go towards retrieval systems instead, or can we hybridize those two, etc. And yeah, another example also here is that, which also showcases some of the problems. One of the problems is that, yeah, the responses that are generated are short. It's difficult to keep coherence, and it's still not very useful for business use cases like these types of generative models. But maybe we are heading there. Again, like I'm posing this question, retrieval versus generation here. And so this is just like a quick look into what we're going to talk more in the tutorial, which is basically following the spirit of the times. Can we actually kind of marry the two paradigms in a sense by doing this unsupervised pre-training, by using our like large models, like transformer-based architectures or like whatever new architecture comes in, and then kind of learn some sort of like general responding or general conversational clues that can be fine-tuned later on using much smaller in-domain data, which are annotated and which we can collect. Okay, so, but we'll again start from the very basics. So again, apologies if some of you really are familiar with those stuff, but we try to make it broad. So basically this diagram here shows the basic modules of your like multi-component modular task-based conversational AI system that starts from speech recognition, converting speech to text, and then you need to kind of understand what the user said, which is the task of the language understanding module. And then based on the previous dialogue history, the current dialogue state, and what the user just said in the previous utterance, dialogue management or policy module has to decide for the next system act, then has to get converted into the actual natural language, most through the natural language generation or response generation module, and then in the final step you have to do like text to speech again with your speech synthesis module. So before we start, we're not covering speech recognition and speech synthesis at all because we kind of consider it out of our research scope. And yeah, it's basically people have PhDs on different modules of these systems. So yeah, it took a lot of effort to develop and continue developing each single module of the task-based dialogue system. So one thing that I forgot to say is basically that the responsibility of dialogue management module is to also interact with like databases through APIs, etc., and also based on the on the returns from the database, decide on the next system act. So now we have to cover other basics. So one of the things with dialogue, as you probably know, is that it comes with a lot of like burden that you have to learn a lot before you actually enter the domain. So with task-based systems, yeah, you need to know what domain ontologies are, what dialogue acts are, and how to define the task in the first case. So basically, we can say that dialogue acts are actually those. A part of dialogue annotations, these are task-specific actions for a particular domain. So here in this example here, so your dialogue act would be like inform the user about the Chinese restaurants, etc. And to actually specify the task, you need to provide this ontology, and ontology can be seen as, I don't know, call it a JSON file, like a collection of slots which are useful for the task completion and the corresponding slot values for each particular slot. So when in the restaurant booking domain, your slot can be food, and then your values could be Chinese, Cantonese, I know, Korean, Cantonese, European, British, etc. And so these slots and values are also part of the dialogue act. So that's kind of, it's like the system act with slots and values is what we kind of consider a dialogue annotation. So this is just an example of several slots and values from the DSTC2 ontology. There's also like a fine-grained distinction between informable versus requestable slots, where informable slots for the particular domain of restaurant search are kind of search constraints. So when you're looking for a restaurant, these are the slots you're going to use to narrow down the list of restaurants you're interested in by saying, yeah, I want like British food, or I want a moderately priced restaurant, etc. And then you can also have requestable slots, which are slots which are more like factual knowledge. So you want to know about the actual phone number of the restaurant, of that particular restaurant, or the postcode of the particular restaurant, etc. So now I'm just going to quickly skim through like the three main modules that we're going to focus on in our end-to-end learning framework. So the first one is language understanding, which is basically, yeah, very simple. It must understand the intent of the user, what the user wants to do with its dialogue turn, and then like inform the dialogue management module about that. But yeah, it's quite problematic, as probably many of you know, working on natural language understanding, because yeah, language is ambiguous, it's varied, and we have so many different ways to say exactly the same thing. So like again, think in terms of dialogue annotations. If you have this like low-level act, like inform food Chinese, you can actually say it in so many different ways. Like, I want Chinese food. How about Chinese food? What about Chinese food? Can you give me an address of a Chinese restaurant, etc., etc. So that's part of the problem in natural language understanding. And like, if we kind of dissect it, it has three main it has like two main modules. So the first module is, let's call it spoken language understanding, which is how it's called in the literature, which is basically trying to understand only the current, most current user utterance. And then the other module is dialogue state tracking module, which is trying to maintain this belief state, which is the actual belief, like the probability distribution of a possible dialogue states in the current dialogue. And basically you can see it as doing the job of integrating the current user utterance to the previous dialogue history and updating what's actually going on in there. While in spoken language understanding can be divided into three subtasks in a sense. The first one is domain classification, the second one is intent classification, the third one is slot filling. So the first one is basically just trying to understand the domain if you're working with multi-domain systems, which is usually quite easy. The second one is quite interesting because you're really trying to understand what the user actually targets. So if the user says, can I make a reservation at 5 p.m., you kind of have to understand, okay, this like low-level intent is initiate booking, so or something like that. And finally, in the slot filling phase, you also need to understand like what slots and values are actually mentioned in the system act. And so basically you can see we kind of decompose it into these like three different tasks for spoken language understanding and two different tasks for NLU. And then the question is, do we model each single task and subtask component-wise, like solve it one by one in a sequential fashion, or do we actually do like joint, call it end-to-end modeling and do like NLU at once, completing SLU and DST at the same time? And there has been like a massive amount of work on both like component-wise modeling versus joint modeling, but that's like the story for some other tutorial. Then the next module, again, like from the very basics, is the dialogue management, which has to decide, given like now, okay, we classified intent, we know the domain, we kind of understood which slots and values are mentioned, we need to decide as a system what to do next. And yeah, and it's called like dialogue policy, which is basically like from a high level, it's a control, it's a planning problem where you're just trying to take an optimal action given the current dialogue state, which actually contains the previous user utterance plus all the dialogue history, and this is actually contained in your belief state, which is the distribution over these dialogue states. And yeah, so system actions are again like generated as these low-level dialogue acts, which we will later on convert into natural language. And there are again like there's a massive amount of work on dialogue management that goes from like really simple rule-based systems that need like human handcrafting, etc., which actually work quite well, but the problem is they don't really learn, so they can't adapt to new environments, to unseen utterances, and they don't scale well. So if you want to move from one domain to another domain, that's a bit problematic because you need to design your dialogue manager from scratch in a sense, or you can just reuse some parts. But as we will see from one table, the problem is that compared to many of like even like deep reinforcement learning algorithms, this is what still works from the practical perspective, more or less. And then like other sets of approaches are based on supervised learning, where you're just trying to, given the annotated data, you're trying to learn to mimic the answers, like the system acts and responses from the given corpus, but it kind of assumes that everything is expected from the humans, so that and you can't go beyond what's in your data in a sense, because when you actually deploy the system in practice, you will have a lot of users behaving in a completely different way than what you actually expected, and maybe the dialogue reward is completely different than what is in your data set as well. So plenty of work actually focused on reinforcement learning and deep reinforcement learning, and although this is like really interesting as a framework, we're still not there yet in a sense. Although like most of the current work on task-based dialogue systems from the research perspective is based on RL. So again, but this is a theme of another tutorial. If you just like reinforcement learning for dialogue, could be like a 4-hour tutorial on its own, right? Yeah, so this is the table I was talking about. So this is like an empirical survey paper done less than 2 years ago, where the comparison was made between, I think, 4 or 5 state-of-the-art, cutting-edge reinforcement learning systems for dialogue management, and they compared to like handcrafted rule-based systems, and what they observed actually was that, yeah, handcrafted kind of wins almost in every single domain tested, which was kind of sad at the moment. We're still making progress and getting better and better reinforcement learning systems out there, but yeah, it's kind of like, yeah, from a practical perspective, always trying to do handcrafting and comparing to it in your particular domain is like a really good practice. And so one of the questions that we often get is also like, yeah, why doesn't reinforcement learning work so well for dialogue when it works so well for, I don't know, for example, for AlphaGo? And it's basically because it's a different problem, and dialogue is much more open-ended in a sense, and it's like a different reward function. So with AlphaGo, it's quite simple, and here it's like, with some people, they don't even want to talk to the system agent because they don't like to speak to virtual agents. So what you're going to do with that? And some people behave in really weird ways, and I think we got all that deploying our systems in the wild. With AlphaGo, it's kind of everything is known. So you just have really well-defined rewards. You have well-defined actions. You have well-defined set of states. Although the number of states is really big, but it's well defined. And so one of the let's call it tricks, but one of the things that people should be aware if they know a lot of machine learning is also when to use it and when to kind of resort to more pragmatic solutions if they want to build something useful. Okay, so the third module is response generation, which I'm just going to quickly go through because, yeah, from this superficial overview, you can't really get a lot. So the idea is basically, again, to convert this low-level dialogue act, like low-level annotation, which contains the actual system act with slots and value pairs, into a natural language response. And yeah, and here you kind of want these responses to be fluent, natural, and kind of varied lot you don't want the repetitiveness so much. And then, like from the research perspective, there's a lot of work on evaluation, and it's hard to evaluate also because I think the best evaluation is human judgments, where they actually really test generated responses based on adequacy, fluency, readability, variation, etc. But we can't really do it because, yeah, it kind of involves having human in the loop all the time for every single domain, for every single problem, etc. So we're trying to get towards more objective, automatic measures. But the problem is that these two measures often anti-correlate. And yeah, so there are other problems as well. So like generative NLG modules often like have a tendency to generate non-fluent or grammatically incorrect sentences, which also annoys people. So going back to that, people actually behave weirdly. So some people might complain about the conversational system just because something was slightly ungrammatical, although like from the semantic perspective, everything was really correct. And so that also makes the whole job of tailoring these systems much more difficult. And so there are other questions with natural language generations, like do you resort to more like template-based type of things, or do you want to again like learn your generators using neural architectures, or do you want to do fully generative models that learn from the data, or do you want to do retrieval-based models that kind of give you guaranteed I don't know, naturalness and fluency of the responses if your predefined set of responses is good? And do you want hybrid models that kind of combine retrieval versus generation, etc.? And there's like a bunch of work on NLG as well, where like people also tried combining different paradigms. And can we also inject linguistic patterns to increase fluency and naturalness? Like, can we do post-processing? So again, like another tutorial. So And yeah, so this is just an example of, like, I think it was the first RNN-based NLG module that does like a sort of, call it end-to-end learning for NLG, where the idea was basically given the dialogue act to generate or like decode the response based on the dialogue act. And yeah, it was kind of what started the whole deep neural revolution in NLG as well. Okay, so this was a superficial basic overview of these three modules, and basically end-to-end learning from the task-based perspective, conversational AI's perspective, basically means trying to learn a system that does all these three things at the same time, like without having this like component-wise distinction. You're trying to get everything work with like a single big network that communicates in a sense. And so it's basically, so this is an example from Wen et al. From 2 years ago, where I think it was maybe the first model that did like a neural network-based end-to-end task-oriented dialogue systems that tried to model language understanding plus dialogue management plus response generation in the end-to-end fashion. So Paweł will talk more about this. Okay, so this was the intro, and since we're going end-to-end data-driven, we need to talk about data now. And so we're going to spend a lot of time now like showing the overview of the current advances in data collection for conversational AI, as well as trying to dissect some of the main paradigms for getting the data. Okay, so yeah, just a recap before we start. It's basically why we chose working on task-based dialogue systems. It's basically because they have a well-defined problem. They solve a real problem, and they like by developing good evaluation measures, we can also like measure our progress as we go, because it's like we can define it in a quantitative way. Well, it's not only about passing the Turing test, and it can be really useful for the current technology, and with well-designed data collection protocols, we can actually get annotated data that can be used to build better and better machine learnable systems for task-based dialogue. So a sort of like a development cycle, if you want, would be, can we actually get a baseline system really quickly, do our machine learning on the data, get it to the users, collect more data, retrain the system, do the relabeling, etc., and kind of repeat the loop and getting better and better systems. But by defining our evaluation measures like task completion or human satisfaction, we can actually really track our progress as we go here. Okay, so why do we need data? It's basically because some of the historical evidence actually teaches us that although like our algorithms can be really sophisticated, Q-learning, convolutional neural nets, it's basically the data, maybe plus computational resources that allow it to actually run our models on the data, is what keeps the progress pushing forward like even quicker. So we have some anecdotal examples here. So for example, it took, I think, for example, with object recognition ImageNet appeared like 20 years after convolutional neural nets, but then we reached human state-of-the-art performance only like 3 or 4 years after we actually got ImageNet. And the same thing happened with Q-learning, where we had that in the early 90s, and it took a lot of time. Actually, it took the whole learning environment that actually started getting the data to train our systems before the machines are able to defeat humans in like the game of virtual ping pong. And it actually happened much quicker. So it's, as you see this like on the upper left side, it's basically rough estimates 18 years from a good algorithm to an AI breakthrough, while it's only like 2 to 3 years if you actually have good data. So, as I said in the beginning, building new data sets is now a hot topic for NLP in general and for conversational AI. So only in the last year, from the last EMNLP conference, where MultiWAS actually won the best resource paper award, we had a lot of data sets happening with like more and more domains covered, with more dialogue turns, more varied dialogues, and yeah, people are trying to be creative also, and that's why we have like these different data collection paradigms as well. And so the first table was taken from last year EMNLP paper, when it was like the largest annotated multi-domain corpus to date. And I think a few months ago, another data set was released, which is, as you can see, much larger than MultiWAS, but there are differences in their design and their properties that we're going to discuss. But yeah, as I said, it's a hot topic, and there are like blog posts about that. And for example, this blog post that we mentioned here was published in beginning of July, and it doesn't cover like 3 or 4 really big and hopefully important data sets that came out just in the last 3 months or so. And there are like some repos of available data sets online, and there's been a survey paper a few years back that tries to really categorize then state-of-the-art data sets in multiple categories, like annotated versus unstructured data, and then like they also divided into human-to-human collected versus human-to-machine collected, and versus machine-to-machine collected, etc. The problem is when you actually collect, as I said, data for dialogue, it's basically you can't know what you need before you deploy your initial system, and then you might actually encounter unexpected behaviors, or you might need to extend your domain. So which means like also extending your ontology, defining maybe new dialogue acts, and yeah, so it's also part of the problem. So like then you need to retrain your models on expanded annotated data, etc. And that's basically also what hinders like collecting really large data sets for the problem, because yeah, sometimes you can anticipate certain things and certain actions, and you know what tasks you want to solve, but yeah, it's usually the end client that defines the rules, and they want maybe something else to be supported, etc. So okay, so starting from one of the maybe most famous data sets in task-based dialogue, which was developed for DSTC2 and 3 in restaurant booking and searching domain. It was generated in a human-to-machine fashion, which we won't cover in the tutorial, because it's kind of, yeah, it's already deploying your system in the wild and then getting the data from humans talking to the machine, which can be seen as like the later stage of your system deployment. So once you actually have the initial data, once you train the system, you put it in the wild, and you might collect more human-to-machine data and annotate it and put it into a data set. So DSTC2 actually had all these annotations that we see here based on dialogue acts and slots and values, etc. And currently, data collection for dialogue is still, let's call it, under influence of how the annotations were done with DSTC2 and 3, which basically, yeah, domain ontologies can be seen as a form of explicit semantics, which really constrains your dialogues, and even like the user needs to know in advance sort of your ontology and what can be supported, and if they don't know that, they get frustrated quite easily. And yeah, we need to build like slot specialized models with the specially annotated data, etc. So another question is, which is also a hot topic right now, is can we build like, I don't know, more versatile data annotation protocols that will allow more freedom, generalization to unseen slots and zero-shot learning, etc. Okay, so, well, the problem, again, I'm just talking about problems and not about solutions, so I've left that to Iñigo and Paweł. So there are so many problems, as you can imagine. So even if you talk about very specialized domains, again, you don't know what to expect from the users. So it could be that, I don't know, the coverage is basically almost infinite because people can mention out-of-domain concepts, they can talk in metaphors, like what about general knowledge or common sense knowledge or common sense reasoning, that if that's not supported. And like also you need to define what means dialogue success, what means user satisfaction in a quantitative way, and then measure your progress. And do you focus on automatic versus user-centered metrics? And also when you can imagine how this scales really quickly to like, what about multiple domains? What about different languages? Do you need to adapt it for different like cultural perspectives? What about politeness in different cultures? Like, do we need our systems to be proactive versus just reactive, where they just like kind of answer questions, or they also want to offer you something? And yeah, if you want to build your system to be proactive, you need to collect the data to kind of push it to be proactive as well. And so you need to take into account all of this while collecting your data and designing your system. Okay, so we are now dissecting two main ways to collect the data for task-based dialogue at the moment. So I already mentioned human to machine, which we won't cover, which is basically, let's call it just ask the system to talk to humans after deployment and then collect this like data, and you can re-annotate it in the cycle. So I'm going to cover machine to machine as the first paradigm. Okay, so the idea is actually quite simple. The idea is to already design or build the whole dialogue flow, which is given in these like low-level annotations beforehand, or like simulate the whole conversation in low-level annotations, which kind of gives you those annotations then for free, and then you get those annotations to humans and ask them to just paraphrase it in natural language. And it kind of removes the necessity of annotation from crowdsources and like human workers to the actual domain experts or like system designers. And so for example, one paper that kind of illustrates the whole framework in a really nice way was published at NACL last year from Parat Shah et al. And yeah, the idea is, as I said, it's quite simple. So you need to simulate, you need to simulate the user, which is, again, it doesn't really make it simple because user simulation is a problem on its own right. And then you build also like a system simulator, which is usually based on on a finite state machine that learns to respond or that you tweak to respond to particular user dialogue acts, and they kind of they proceed in doing this what they call self-play. So you define the set of dialogue goals, and the system needs to respond to the user acts which are associated with those dialogue goals, and then you convert those low-level annotations into like templatic utterances, which are not natural language, and then you give it to the Turkers to paraphrase it to natural language, and then you can further train your models by running the user simulator that will actually encounter dialogue flows that were not present in your initial training data, or you can really deploy it to humans and collect human feedback for your reinforcement learning algorithm. So that's the main idea. And yeah, so this is the overview. So what a developer has to do is provide all the task-specific information. So we need to define our domain ontology again, and like our slots and values, etc. But the framework should be task-independent. So once you actually illustrate, once you provide all the specifics of your task, of your domain, you can actually easily run it in this generic framework. And as I said, the outline generation, so the dialog flows are generated by doing the self-play between users and system. And the outline is a sequence of templatic utterances and their corresponding annotations. So I said like templatic utterances are basically non-natural utterances that get converted to natural language, and annotations are, as we saw, like dialogue acts with slots and values. And so based on this figure here, they claim that it can be done quite easily, that you just need like 1 working day to get the data for your domain, which is of course not true, because you need like maybe years of working in the field to get it. Okay, so this is again like the overview of the whole structure, maybe in more fine-grained steps, where we also show that, for example, in the data simulation phase, once you collect all these dialog outlines, the developer can also take a look and maybe remove some of the dialogues they're not really happy about, or you can also customize it to really focus more on the predefined flows that you really want to cover in the data set. Or you can also subsample a big data set to maximize the coverage over different slots and values, because you want to, maybe you want to learn more quickly. So from the pragmatic point of view, we tried this. It's basically by doing this subsampling to maximize coverage over different dialog acts, slots and values, means that you can train on like almost like 9-10 times less data and get pretty much similar results. So the idea is maybe to over-generate and then subsample. And so you can allow human in the loop for pragmatic purposes, where like the developer can take a look and see what's covered, and then you can also have like multiple cycles where so you deploy the whole thing, and you realize, okay, some of the dialog flows are not covered, so I need to collect more data for that, and then you just do machine-to-machine data collection for those particular flows which were not covered in your initial data set, and you can do it multiple times before you actually get the full data set. So this is again like the breakdown of the whole pipeline, where you first need to define like a user goal, which is basically your dialog scenarios. So maybe a user wants to book a restaurant and then decide that she doesn't want to book it, or the user just wants to ask about a Chinese restaurant and then like finish the call. Or another dialog scenario might be I don't know, searching for the restaurant, then deciding to book it for that many people, etc., etc. And you can pre-specify all these things with pre-specifying the user profile and the system profiles, which means like the user should be really consistent. So you can specify, for example, the maximum number of repeats if the system didn't understand something. You can also pre-specify in the system that the system sometimes doesn't understand, because that way you're kind of anticipating this behavior when the system couldn't really respond immediately to the user's need. And then based on the user's goals, you create what we call the user agenda, which is basically converting the dialog scenario into these set of dialog acts. And then you do the self-play phase, where like the user and the system converse, but in the dialog acts, you need like a rule-based conversion from dialog acts to these templatic utterances that you finally give to the Turkers to give you your natural paraphrases. So what the developer has to do is define possible system acts, which is also part of designing the actual task. You need to customize or control the system behavior by setting the parameters of the system. You also need to control the simulated user behavior by specifying the parameters, hyperparameters of the user, and you need to model, hopefully, like a task-independent interaction between the system and the simulated user. So given the current state of the dialog, you can actually pre-specify these transitions from one state to another. So it's usually done by doing like an FSM on with different dialog states that the dialog can be in. Okay, but there's another problem. So you can't do this without solving the difficult problem of user simulation, which is can we replace the real human user with a model that completely replicates how the human user will behave? And again, like you can do it in different ways. You can do it in a rule-based way, or you can do it in a learning-based way. So you have like a lot of neural approaches now that try to just solve the problem of user simulation, and they have their own bag of problems and different evaluation measures and different approaches that don't work really so well. So it's basically, so you see a problem here. It's basically, can you collect high quality data for conversational AI if you haven't solved properly the problem of user simulation? So what actually works in practice, and many of these many of the papers that focused on data collection used just like a simple rule-based approach, which is work that is like almost 15 years old, and it's based on agenda-based learning of defining these scenarios and user goals, and then like doing the like FSM-based interaction between the user and the system. So yeah, so I kind of said this already. So most of the data collection based on M2M is still based on rule-based systems where you need what we call the user agenda and a goal, and you fix the goal, which is the set of dialogue acts with slots and values that have to be fully completed, and then the interaction goes by putting more. You have like a stack or an agenda where you put more actions on top of the stack, and those have to be resolved in a first in last out basis. So here's an example from the paper, and yeah, it's quite simple. So I haven't seen any data collection work that actually relied on like neural-based user simulator to date, unfortunately. So it's an interesting question, like to just kind of compare data quality if we do both, like a comparative analysis. Okay, so, but what we can do is a sort of a hybrid approach where it's not fully machine to machine, but we also get some humans in the loop, like some users in the loop. But where you kind of, you collect your data in a machine to machine fashion, you select some like, I don't know, like a experimental group of people, and then you try to improve the data by working with those people, getting their feedback, and then you kind of deploy it in the wild and collect more data, maybe in a human to machine fashion. Of course, all of these choices, like if you work with experimental groups, if you work with actual users, if you work with like fully simulated users, they have their pros and cons that you can see here. Okay, just to recap, I've said this multiple times now. So one of the things is to take away is understanding the differences between low-level dialogue annotations versus these like non-natural templatic utterances that get that are annotations converted, and then you need to paraphrase them into natural language. So one of the important properties of the machine-to-machine protocol is basically that the actual crowdsourcing work is much easier than with human-to-human, which you will see quite soon. So crowdsourcing is basically just collecting paraphrases, natural language paraphrases of these templatic utterances, and it can be done in a very easy fashion. So, for example, these are all the instructions that were given to the crowdsourcers to do the task, which is much simpler than just telling them, okay, this is the dialogue scenario, blah, blah, blah. You need to define another sub-scenario, etc., etc. And it was, so one dialogue outline was given to more than one Turker to generate natural language paraphrases to ensure variability of the language, to kind of cater for like different styles of conversations, etc. So finally, we just prepared a few slides, which is machine-to-machine in practice. So Anton Bord et al. Actually created one more like a diagnostic data set, which is included in Baby, which was actually simulated so that each dialogue has these stages of completing 5 well-defined subtasks of a restaurant booking system, and it's mostly to basically benchmark how current state-of-the-art systems react on all these subtasks. So like Subtask could be initiating this API call or then updating it based on what the user said, showing the results to the system, and the fourth one is providing extra information more than the user actually wanted, and finally task completion of the full dialogue. So it was a small system, but it was generated that way. And I'm just going to quickly skim through a very recent system, data collection, data collected for DSTC8 based on machine-to-machine, which is a schema-guided dialogue, which was used for the schema-guided dialogue state tracking challenge. And I think I don't have more time for this, but it's very new. It's just been published. It will be used for DSTC8. Actually, it was used because the evaluations were recently. And yeah, the idea is basically pretty much the same as the M2M protocol that I just described, with one twist, which is adding descriptions to your domain and to each slot, which kind of gives you this generalizability capacity where you can also link similarities between different slots and different services or domains based on the similarity of their of the embeddings of their descriptions in natural language. And it's kind of and one of the reasons is because of the whole BERT thing, because BERT can actually learn from these descriptions. So the dataset currently covers, I think, 16 domains in training. One domain is put only in tests, so like 17 domains in total, and the number of dialogue is much larger than what was previously in DSTC. Yeah. Okay, so I'm gonna skip these slides. It's more like different properties of the schema-guided dialogue dataset where, as I said, you can like link very similar slots from even like different services, like number of seats versus number of riders, and yeah, getting a ride for ride sharing in one task and another task. So yeah, I think Paweł is quite impatient. So so I'll leave it to with this slide, which kind of lists advantages and disadvantages of the machine-to-machine protocol, and yeah, you'll have some time to think about it before we go to the human-to-human data collection.
Hi, it's not that I'm impatient, but I was texting Ivan that he's definitely he's gonna steal our time, me and Iñigo, and that of course happened, so that's why I was laughing. So going to human-to-human conversation, I wish I'm gonna say that you should forget all what just Ivan said about M2M approach, but I'm not gonna say that because it's being recorded. But I'm really biased right now presenting that because the last 3 years is basically just working on figuring out how to collect properly the data, at least for research purposes and finding the better challenging problems in terms of the dialogue, task-oriented dialogues. So when I am saying that we should forget about M2M, well, basically M2M is all about solving the problem in the first place that we are actually focusing on. So having a user simulator and having a system working for you and even creating simple dialogue flows is the research on its own. And basically, if you start working on that, you're going to introduce bias by definition because your perception of the world is completely different from the one that's your final customer. So basically, you're building dialogue flows that have some of the time they're not related at all with reality, which actually you care about. Because at the end of the day, whether your user is satisfied is your final goal, at least in terms of the task-oriented dialogues, right? That's why Wizard of Oz is a completely different paradigm in the sense that we are trying to make people talk the way they wanted to talk, and that we are trying to learn from it. So what would happen? In ideal world, we are working for some company, so you basically provide your, for example, if you're working in a call center, you provide your workers with some UI where you track all actions that the worker is doing with the client, right? Of course, none of us probably works in a call center, so the task is a little bit harder. So what we could do is to reach out to crowdsourcers, and basically by giving them a channel to talk to between each other and some specific task, we can create the environment where we're gonna be tracking all their actions to get data. So that would result in hopefully way more natural conversational flows that you would have with M2M. And naturally, there is a lot of problems with that setup too. But over the last 2 years, I think it was at least way more popular in terms of the data set that we are obtaining for research purposes. So procedure is, as a general flow, is pretty simple. What you gotta do is to put 2 people in the chat. And I'm going to discuss later that actually it might be way more than just 2 to speed up the annotation, but let's leave it for now. Given these 2 ones, one side needs to be given a predefined goal, so that he will know what we are talking about, not just set up and talk about whatever you want, but something well specified. And once you're going to have that, we're going to be recording either the conversation through speech or through the text. But most importantly, we want to create the ecosystem where we're going to track as much as possible of the actions of the system side. So basically, this will create that for us collection of the most important middle level annotation that can be reused along the training of our whole dialogue system. And probably at the end of the day, you will need to do also post annotation over the collected data, if you want to focus on more particular NLU, for example, problems or policy optimization. And unfortunately, for especially Wizard of Oz, system data cleaning is a must that I will cover a little bit later. So going to step by step, I wish I could say that instructions for Wizard of Oz is just also this couple of sentences, but it's not true. This is a site for the user. But the main point from here is that the less stuff that you're going to put on the instructions when you're collecting this data, the better. Most of truckers don't read them anyway, so at the end of the day, it's just a check for you that your model is properly well defined. The most important part from the user perspective, so the M-Trucker who's going to be pretend to be a customer, is to create as much as simple as at the same time as a well-defined goal that he will need to cover. So what you can do is to basically define a role, and then, for example, domains, if you're talking about complex conversation, gradually along the conversation. If you're going to do it properly, then you can end up arriving at pretty complex dialogues that will cover multiple domains. For example, finding the attractions, then finding a train, getting the price of the train, and so on. The clue for that here is that you gradually show the goal of the user, so it doesn't. The cognitive load for them is not big, right? So if you properly set up the whole UI. For example, in the case of user side, if the user task is being gradually shown to the user along the dialogue, then it's way easier for them to actually have way more complex dialogues than just throwing at them the big task. So in terms of creating the UI, for example, for the user side, is a must, of course, on top of the user task is the dialogue history. And if you want to, and of course, that the field where they are given a response back, but also you can add additional stuff that you can collect, like, for example, defining what the kind of domain we are particularly in our conversation, and any other stuff that you actually need to collect. So that's the user side, which actually is the easier one. Because what we care about in terms of Wizard of Oz is, of course, our system. So from the system point of view, Wizard of Oz operates in similar ways in terms of dialogue context. Of course, the user needs to know what is the dialogue context. But the clue of the whole thing is database GUI. So you can imagine that we have to create the UI for the Turker that will be pretending to be a system or the worker in your company, where we easily can track all the actions. In terms of this simple scenario, for example, the multi-was was just tracking, for example, hotels or restaurants. So that's basically a SQL query. But the beauty of this thing is that basically you can tell your mTurker that they just need to find the restaurant, and that's all you need to do. And then giving them a nice UI for them to query the database, internet, whatever it's a source of the knowledge, in the way that we can track what they find. And finally, of course, the system response. What happens here is that basically the Turker doesn't need to know much about the fact that for us, all we care about is actually the annotation that we're getting from him sending the SQL queries to the database. Of course, you can imagine putting here instead of, for example, Wikipedia articles or any source of the knowledge that you actually care about for your given task. So at this point, we have belief state, as we call it, as even defined before. We have, of course, conversation. What we need for example, for policy optimization or natural language generation is the annotation of the system utterances. And in order to do that, we can run another post collection, where again you show at least as simple as possible UI for the user, where given the dialog context you can choose the domains and then start choosing dialog accents, slot value pairs that the system sentence that the system side uttered. That's impossible to get from the user side in as easy way as the system one. So the question here, how to acquire high quality labels for the task that is way more challenging than just talking to each other. And it creates also a lot of confusion between NLP practitioners on a daily basis too, because everyone has a different definition of dialog X. So what you can do is to basically create a two-step approach where you first find a subset of Turkers that are performing and understanding the task, which is sometimes a problem, and only given the chosen subset of these people, you can run annotation on the full data set. So a couple of tips in terms of working with mTurkers in general data collection, and the lesson that we learned, both from practical industrial point of view and research one, the easier task you have, the better. So basically, a one-click task would be the dream. Of course, is sometimes not possible, but the smaller cognitive load, the better. As I said previously, and even mentioned that the shorter instructions, the better. Most of them don't read it anyway. What is also a must is a high entry bar that also often people don't that forget about it, is the approval rate, for example, should be for mTurker or a worker on any other crowdsourcer platform should be pretty high. The same with location. I think the general belief is that, for example, mTurker site is multinational. From our experience, not really. It's a great support for English language, but there's been, thankfully, a lot of variety of other different platforms, like, for example, Prolific, that gives you way easier access to multinational workers. That comes with the price. They are more expensive. But hey, again, if you're thinking about, in general, getting the data for more NLU advanced task, definitely running qualification verification task is a must to obtain the higher quality data, and then you will end up creating a subgroup of workers. So how does it work in practice? Of course, I will have to talk about multi-was, but I will cover off other different data sets too. And at this point, I would like to give the tip for academic people who are thinking that they don't have resources to gather the data. The whole collection that we did, for example, here back in academia, was entirely funded by industry. There is plenty of money at the table. You just have to literally apply for it. So shout out to anyone who is thinking that it's not possible to do. What we did, it was setting up the scenario where a tourist was visiting Cambridge, and there was an information clerk that had to give all the information that the visitor needed to get. we wanted to move one step forward from DSTC2. That's why we introduced a couple of domains, and that's where the challenge mostly comes from. And final nice thing is that DSTC8 quickly embraced that as a multi-domain task completion challenge that we'll cover a little bit later. At this point, this table is not really that useful because we have way bigger data sets. But it was good to know that we started talking about data for real in terms of dialogues instead of just using DSTC2 all the time. What it looks in practice is that we could run entirely based on mTurk data collection, where we define a lot of act types and slots that then mTurkers could annotate, and then that are useful for policy optimization or NLG problems. A couple of observations. Thanks to more complex scenario of collecting the data, most of the turns are way more complicated than usually, with many intents or many dialogue acts that you need in order to model the system side. So way more exciting in terms of complexity. The same with, for example, the frequency of sentence or length on the system side. So these sentences from the system side are way longer, and that's what we were aiming for. So you can achieve it entirely through mTurk outsourcing. And this then was translated to the challenge where basically single is now substituted for multiple. But not going into the details because we will discuss the results a little bit later. They were actually posted a couple days ago, so it will be fun to discuss basically in real time. Funny enough, Google also at EMNLP showed the paper about air dialogue data set. I don't know if Weiwei is here, but it was promised that the data will be released. It's been 1 year and the data is still not released. So why I'm saying that, because what was advertised is actually air dialogues as 400,000 dialogues. So we can imagine what we could do in terms of end-to-end learning with that kind of a size of the data. Unfortunately, it's not available. Weiwei was actually using one domain was our dialogue data set, but the pipeline is exactly the same as we mentioned before, which was a word of us, although they constrained to in-house annotators. Really nice domain, fantastic size, but the lesson to learn before we actually going to talk about end-to-end modeling is that if you look at the numbers of humans versus the best models that they could achieve, looking at the column total, we are reaching around 22% of success rate versus 94 for humans. Even humans cannot, make all of the tasks perfectly. Sometimes you just make mistakes when you're querying the database or you didn't understand the user. But the lesson learned here is that even you have 500,000 of dialogues, literally talking about 5 intents, which is booked, changed, not, flight, found, cancel, no reservation, that can be summarized for a human in basically 7 sentences, you're nowhere near solving the problem. So something is either entirely wrong with the way we are structuring the problem, or our models are not there yet in terms of the structuring side. Finishing with the key properties of WAS. What we're getting instead of M2M is a little bit more natural conversation between real people. I'm saying a little bit because at the end of the day, they are not your final clients, right? So we are trying to lie to each other that this is more natural. Of course, it's in terms of dialogue flow, it is, but it's still a little bit far off from the real users. The good point is that we don't need to simulate users in the system. So you spend most of your time working on the UI for Turkers or for people who will be creating the data, rather than the building a user in the system. In general, when you find this, when you start collecting the behavior, is expected to be completely sometimes funny and ridiculous, so that you learn way better system behavior. And what you could actually do is you don't even have to set 2 people in one room to talk to each other for a couple of minutes, because it's also a quite big expectation for them. You can actually run this collection by turn. So at this point, you're only constrained by the budget because you can, for example, the whole MultiWOS can be easily collected once you have that whole setup in a matter of one day, which is pretty cool. I talked a lot about nice properties, but there's a lot of course, disadvantages of the stuff. You need to put a lot of work for creating a simple UI for the mTrukers so that the cognitive load is as small as possible. It's highly subjective how we then define, for example, the schema of more granular annotation that you kind of solve in the first place when you're building M2M approach where you have a user in the system. And then translating that for annotation is a pain too. You don't have control over dialog flow, so you don't really know if what you collected is entirely going through the whole space of the possible conversation in a given domain. You have to just believe it that, for example, 500,000 dialogues is enough. And data collection is very noisy. For example, lesson that I learned is actually Amazon people. I don't know if Michal Eric is here, but for example, MultiWOS post-processed then and cleaned well, but quite a lot of margin because the data collection was very noisy, even with the high bars for mTrukers. And with that, I'm finishing my part, and the last part will be real conversation data collection with Iñigo.
Hello. So yeah, I'm going to start talking about real conversational data collection. And what do I mean by real data? It's not real what we have been seeing so far. Well, the problem with Turk data is that it's not data collected in the real scenario that you are trying to model. No? So whenever you ask a closer, sorry. Well, what I was saying that this data, even if it's real, obviously, is not as good as data that you will collect in the real scenario when you have a client really calling a restaurant or something. Why? For several reasons. First of all, the user is kind of biased by the scenario you are giving them. You are telling them, yeah, you are going to do this. They already have like their mental scenario of it, and it's not going to like they go to the restaurant, they don't know what to say, and so on. And also this happens that all this data becomes very homogeneous in the sense that Turkers are kind of like they just want to do their task, get paid, and whatever. So they are not going to be very creative in ways to say things differently and so on. And as I said, as they are biased by the scenario you are giving them, you're not going to get many variability here. So where can we find real data? So for the last huge NLP models such as BERT, ELMO, and so that have been trained lately, they are used in huge corpora of things like Wikipedia, books, other kind of documents. The problem is that this is not conversational data. This is good to model some other NLP task, but if we want to create models for conversational tasks, we need data that follows the same distribution as our tasks. We have movie subtitles, which we have some corpus which are quite large, including this. This corpus includes some conversations, but they are not totally composed by conversations. Sometimes you have the narrator speaking, they are not properly divided in turns and so on. So, but technically, I mean, we can get conversations on the internet. I mean, the internet is technically full of conversation. It's a communication tool used by millions or hundreds of millions of users every day, in which people is continuously interacting there by natural language. These are technically conversations. So what kind of conversations do we have in the internet? For example, in social media, whenever someone posts something in Facebook and someone answers, this is a conversation. Maybe it's a conversation that only spans one turn, but this is still a conversation. Same for product review sites like Amazon, Yelp, TripAdvisor. Here you have people continuously interacting in natural language. Same question-answer sites and so on. And then lastly, and probably most importantly, you have general discussion forums. I just mentioned Reddit here because probably Reddit is bigger than the rest of general discussion forums altogether. And here you have people every day talking about a specific topic for several turns, many different ones, and so on. So this is a great source of data that we have there and available. But well, the data is there in the internet, but what data can we actually use? What data is, let's say, publicly available, publicly released as dataset? So during the next minutes, I'm going to review some of the data sets that have been released with this kind of real data. Sorry, yeah. The first corpus that was released was the Ubuntu dialog corpus. So this is around 1 million dialogues that for the date that it was released was huge compared with any other dialog corpus seen before. These are chats from the Ubuntu support IRC channel, so basically people that has problem with the Ubuntu operational system and technicians that try to help with the problem. So this is obviously a very domain-specific dialogues with very technical words and so on, but still, for many years, this was the only large data set that was available, so has been very widely studied and, for example, has been recently used in DSTC7 as one of the main tasks. Then another interesting conversational data set that has been around for several years is the Amazon question answering data set. This is basically questions and answers from Amazon products. Basically 3.6 million question answer pairs. This wasn't originally released for conversational research, but this is useful for conversational research, even if only has single turn interactions, so it's not good to do, let's say, long-term contextual conversation. It still has like a lot of conversational interactions there. It also has product and category labels, which means that you can go further and just doing other conversational tasks such as, I don't know, conversational product search and so on. Then the third dataset I'm going to talk about is the Open Subtitles dataset. This dataset was originally released for machine translation because basically you have subtitles, you have, let's say, parallel translation in 62 languages. But still, as I said before, these are movie subtitles. You are going to have a lot of conversations in these movies. Obviously, you have many topics. You have movies about many different topics, documentaries, TV shows. So basically, the scope of this data is going to be very large and diverse. It's multilingual, which is always great because most of the data we only have it in English. So if you want to have, like, it has a lot of Spanish, French, Chinese, a lot of many language data. And well, it has obviously some problems. As I said before, it's divided in sentence fragments. It's not really divided on dialogues. So a lot of times you don't know if it's the same speaker speaking for several sentences, if is there an interaction there. A lot of the interactions are very dependent on the video. So a lot of times the conversations don't really contain any information or don't really make sense if you are not seeing the video and so. Or sometimes they are very history dependent, no? So if you want to kind of like, you really need really large spans of conversations in order to make them have any sense. And lately I'm going to talk about their data set that I think is the best of all out there for conversation, for let's say large conversational research. This is the Reddit data set. This is by far the largest corpus out there. It's composed by 7.3 billion comments, spanning many, many topics. I mean, any one of you that has been in Reddit knows that anything that you can think about, it's probably going to be on Reddit. It's super conversational. It's just people talking with each other. And a lot of times these conversations span many, many turns. A lot of times the turns are going to be not by two speakers, but by several speakers answering to each other. But still, it has a very conversational structure. And it's continuously growing. So as people post more things on Reddit, you can get all these interactions. So basically, it's very up to date. Any very actual topic that is happening right now, you will get this data in this data set. Obviously, the problems of this data set is, well, it's Reddit, it's internet, it has a lot of hyperlinks, memes, images, a lot of non-grammatical language, internet slang. So in other words, the data set is very dirty. But still, the size of it makes up for the problems that you get from having so many, let's say, noise in the data set. And funnily enough, this data set, there is not a paper for this data set. This data set was kind of released by one data analyst called Weizenbaum, which he just posted one day in one Reddit post. I used the Reddit API to just collect all Reddit comments from 2005 to today. And he put it there, and well, I guess that we have to give him some credit for it. So the problem with most of these data sets is, as I have said before, most of them, they weren't released for conversational AI research. So for example, the open subtitles, mostly for translation. Amazon QA for QA. So like this year at PolyAI, we tried to collect in a repository what we thought it was the 3 most useful, along with the Ubuntu dataset corpus, but that's already in a nice conversational framework. We put them together into this repository where basically, for example, with Reddit, what we are doing is downloading the data, cleaning it in order to remove like very long sentences or very short sentences, also removing like all these images, hyperlinks, and so on. And basically, yes, put it in a nice format that can be directly used for a wide range of conversational tasks. So in this slide, just to give an example of the difference of the data sets we were working with 5 years ago with these data sets, we can see the number of terms in each of these data sets, like this is 2 and 3, and even multi-WOS that is only a couple of years old, they have, let's say, up to 4 orders of magnitude less terms than, for example, the Reddit dataset. Obviously, this dataset has downsides. It's not just you have like a 5 orders of magnitude bigger dataset that works exactly the same. Obviously, the biggest downside is there is no semantic annotation at all, and you cannot semantically annotate them. It's like they are too wide, too big, too... So basically, you won't be able to do many of the traditional way of training models that we have been doing so far in Dialog. And also, it might be difficult to get task-specific data. I mean, you will have a lot of conversational data out there, but if you want a specific task to book a train in this specific city and so on, it's very difficult that you are going to find dialogues just talking about that. So, and finally, like, this is just kind of a mention, as I said, the internet it has so many conversations out there, but most of it, I mean, it's there, you can access it. It's pretty easy to create a data scraper that is going to collect those conversations. But yeah, I mean, I'm not sure how the legal framework works here. I mean, I think you can get it and train a model for yourself. I'm pretty sure you cannot profit from it, for example. But the point is, like, it will be very useful for the research community. Most of these companies that kind of own this data and they have it then like forgotten in the internet, it has been there for many years, could release at least small parts of these data sets, because this will be very helpful for the research community. And that's it for the first part. Now we will have a coffee break. I think we come in 15 minutes.
We have 30 minutes break just to chat amongst us, I guess, to incentivize the research community. And we're going to give back at 4 p.m. for second end-to-end part and building models.